Hey everybody, um, it's Homer White here again. This is the first of our uh, Chapter 12 database screencasts. Sorry, I'm sort of getting myself set up here. Curious to see if I'm still embedding my webcam. I can't see it at the moment. Um, well, we'll just think about that. I'd like you to follow along. You'll want to open up the file on the common folder under Documents, nycFlights13 BB DB practice or markdown file. And you'll probably want to save it to your home directory so that you'll own your own copy and can modify and knit it. Okay, so this is our first practice in making data wrangling types of queries using SQL, structured query language. And we're doing it through the medium of R. This is the way that you'll use SQL in most applications. It'll be through the interface with some general programming language, whether it be R or Python or Java or C or whatever. People have written packages for these languages that allow you to connect to SQL databases and to make your SQL queries through them. So there's various versions of SQL database systems, and we're going to start off with SQLite. SQLite. It's not a real database system in the sense that it doesn't live on a hard drive somewhere taking up hundreds and hundreds of gigabytes. It's instead the database is created and lives in the memory of whatever session you got your programming language in. It has useful professional applications. You can read about SQLite more on the web. But for us, it's just a little quick first practice for making simple queries from a small database that we cook up within our R session. Ultimately, you're going to work more with other database systems. We're probably going to be interfacing with MySQL systems and possibly with MariaDB systems. MySQL is now owned by Oracle. It was once open source, and when it was bought by Oracle, people got together and put up the MariaDB project. MariaDB's SQL syntax is intended to be very, very close to MySQL's. And so what you learn about one is transfers to the other for at least elementary types of applications like we do. Anyway, you'll be constantly referring to the online document for these systems at these links here. And quite often, if you Google a problem, you'll get referred to some of this online documentation. Other documentation on SQL in general, W3 Schools has a nice site, and it's particularly good for having a lot of worked out examples. So typically, if you Google your SQL problem and throw in W3 Schools, then you'll come to an answer on that site, and it's very useful, I find. So when we're interfacing with SQL in R, we're going to want to library the DBI package, Database Interface Package. There's also another package installed on the server, R, SQLite, and it allows you to create a connection to a temporary database-like structure using the SQLite framework. And with it, you can easily populate the database with data tables. So what we're going to do, I'm correcting myself as we go along, is create a database out of the nycFlights13 package that we worked a bit with in the fall. So we're going to want to library that package. And now we will use the SQLite function inside of the RSQLite package to create that database. And then the results of that shall be fed into DB Connect, which comes from the DBI package, and it sets up a connection to the database. So we run this line, and you'll see DB over here in your global environment. That's not the database. So like if you click on the little arrow, the structure there is not like the tables inside of the nycFlights13 package. It's other stuff. It's just the connection to the database. What we need to do is to write the tables into that database using this DB connection. That's done by the db write table function in the DBI package. So we're going to write in the airlines table, the airports table, the flights table, the planes table, and the weather table that come from the nycFlights13 package. And now we've got this little database inside our R sessions memory. And we'll just practice making some queries from it. So you're going to want to review what's in these various tables from nycFlights13 by doing such things as asking for help on them to remember what the names of the columns are and what they mean. Now, we're going to make SQL queries from the database. We're basically going to be wrangling data, acquiring and wrangling data. It's like what we do with dplyr. So just to remind ourselves a bit, I'm going to library dplyr here. And let's take a simple wrangle where we look at the flights data table and just select out 4 columns from it and only ask to look at the first 5 rows. Ta-da! Okay. Now, how would you do that in SQL? Well, first of all, you can issue your SQL queries through a code chunk. All you have to do is, instead of having an R in the curly braces of your code chunk, put SQL, indicating that the code engine for that chunk is no longer R. It's this other language. You also need to specify what database you're connecting to. And so you'll always have that as a second argument inside your chunk options. Connection is the name of whatever connection you set up. So you'll notice that the SQL syntax looks different. You select your desired columns, then you say what you want to select it from. And the limit here is the equivalent of the head function in R. It's also kind of important in SQL to use limit a lot of the time, because sometimes the tables that you get out are enormous and you don't necessarily want to drag all of that stuff down in a real professional setting. It might take too much time and gum things up. Okay, let's run this little code chunk, and you'll see the results are quite similar to what we had before, but there is a slight difference. dplyr figured out that time hour was some kind of a date time and brought it in as such, whereas SQL brought in time hour as the number of seconds since the Unix epoch on January 1st, 1970. So you just want to keep those kinds of things in mind, that there are slight differences in how different database systems will sort of interpret the data in them when you make queries. And so you might have to transfer this little double vector, into a date time before you do some of your regular analysis. Um, so when you select columns, you're using the standard names of the columns that are in the actual data table. For example, here, we would just like to see the name, the latitude, and the longitude for the first 5 airports in the airports data table. There they are. What if you wanted your table to show nicer looking names, like instead of lat and lon, how about something more explanatory? How about something more explanatory than just name here for the name of the airport? Well, in dplyr, you would use the rename function, but in SQL, you use the as keyword. You select name as airport, lat as latitude, lon as longitude from airports. And so the result would look like this. So that's kind of nice. You can rename or abbreviate columns. Now, strictly speaking, the as keyword is optional. You can get the same thing if you put your rename right after the actual column with no comma in between. Okay? What if you wanted to do something like transform some of the columns into something new? We have lots and lots of transform type of wrangling functions in R for dplyer's use. What about SQL? Let's check what this next code chunk is doing. Oh, cool. So for each airport, the location of the airport is given with an ordered pair of coordinates where the latitude is first and the longitude is second. How did we get that? Well, we're selecting name just like usual, but the next thing we're selecting is some transformation function on the lat and the lon columns of the airport's data table. And we're using a little double pipe operator that SQLite has. So we take the string, open parentheses, stick that right next to the lat, then stick right next to that a comma and a space, and then stick right next to that the longitude, stick right next to that closing parentheses, and we're saying that ought to be brought in as coords. So that's all very cool, but that's how SQLite does it. If you were working with, say, MySQL, then you use a transformation function called concat. So that's very, very similar to R's paste 0. And you just have the arguments to concat, kind of like in the R function, separated by commas. You'll get the same thing. Error, no such function. Oh, that's right. Sorry, I notice I have eval equals false here, and that's because, right, we're working with an SQLite database. It doesn't understand concat. But if we were working with a MySQL database, it would be cool. A little bit more practice, kind of mirroring some of the stuff that you see when you read the textbook on SQL queries. How would SQL mimic dplyer's group by and summarize? Well, SQL has a group by keyword, and that works in tandem with that select keyword. But you have to throw in an aggregation function, just like when you summarize, you have some aggregation function that you summarize by. So, for example, what if you wanted to get the sum of all the flight times? For all the flights from each of the 3 New York City airports on, say, June 20th, 2013, then you'll be using the SQL's sum aggregation function like this. So here is where you're filtering. It's the equivalent of dplyer's filter, filtering down to June 6, 2000, June 20th, 2013, you're still selecting from flights, but when you want the total time, well, you want to group by origin. So notice that's done kind of at the bottom, which is a little weird for those of us used to dplyr. But once it understands you want to group by origin, then when you look up here at this next thing you're selecting, sum of the air times, it's going to sum up the flight times for all of the flights that day from each airport separately, because you group by the origin. So let's give it a try. And there we go. So from the EWR airport, on that day, the flights that left from it took a total of 53,317 minutes in the air. So it's so the group by summarize in SQL is kind of backwards from the way you would work it in dplyr. The sum aggregation function is useful for producing tallies. We've been using the in function in dplyr a lot for that, but you can use the sum function in SQL. So here we are. I'll just run it first. All right. We've grouped the flights by their origin and their destination. And what we want to find out is on June 20th of 2013, how many flights went from a particular airport to another particular airport. And so we find that, for example, there were 16 flights that day that left EWR and went to Atlanta. So how did it work? Well, we're grouping by origin and destination together. And then to get the tally, notice we're selecting sum 1. The idea is it's as if you were creating a temporary column in the data table flights that just has ones running down it. And so once you've grouped, then when you sum 1, that's the same as counting how many rows were in that group. So that's nice to remember. Here's another question. Which destinations are most common for flights that start out from JFK in the year 2013? Okay, remembering that all the flights are in the year 2013, we're not going to have to filter by year, but we will need to filter where the origin is JFK. Let's check and see the results first before we analyze further. So those are the top 5 most common destinations. So how did we get it? Well, we needed to group by destination so that we could add up like the number of rows within each destination, and that's happening as sum 1 here. We're renaming it as num flights. Once we've done all that grouping, we wanted to find the 5 most common, so we need to order by the num flights variable. We wanted from highest to lowest, so we had to stick in desc because otherwise it would by default go from low to high. We wanted the 5 most common as well. It's an interesting exercise for you to review your data wrangling by rewriting this command as dplyr and trying it out on the regular nycFlights13 data. So there are a lot of other aggregate functions that you in SQL that you can learn about. In fact, there are places on the web that'll like list them all. The min is used here to find the quickest flight from each airport. So what are we going to do here? Well, we're looking here again at June 20th, 2013. but we're grouping by the 3 origin airports in New York City. And within each group, we're looking for the minimum of the air times for the flights that left that day, from that airport, and we're calling it airtime. So we're also grabbing what was the name of the flight and what was the place that it was going to. So let's see how that works. So the fastest flight that left from EWR on that day was flight 4276. It was headed to BDL, and it only took 28 minutes to get there. It might have been tied with a bunch of other flights. We won't really know. And so maybe alphabetical order or something like that might have been used to pick out one. Which destinations from JFK had the lowest average arrival delay times? The AVG, which is like the mean, that's the summary function that is used in SQL. And so if you group by destination, then when you average up the arrival delays, you'll get the average arrival delay at each of the destinations. And we wanted the lowest average arrival delays, so we're going to order by the mean arrival delay. There we go. dplyr does joins, SQL does joins. Say that we want to find 5 most common destinations from JFK in the year 2013. But we want to provide the full names of the destination airports, not just their 3-letter codes. So think about how this would go in dplyr. You could start with flights, and then you could filter for the origin to be JFK, and then you want to group by destination and summarize numFlights equals the call to the end function, so counting up the number of rows in each group. And so that would tell you the most common destinations, but you need the full name of the airport, so you do an inner join with airports. Now, airports as a data table has a bunch of columns in it. You really only need the FAA column that gives the 3-letter code for the airport and the full name of the airport. So I'm just going to interjoin with the selection from airports. And I do it by dest equal FAA because dest is the name of the destination airport in flights, whereas FAA is the code for the airport in this airports table. So once we've done that join, we only need to report the full name of the airport and that numFlights that we created earlier up here. So we select that out. We arrange in descending order numFlights and look at the first 5, and there we are. So how would you do this in SQL? Well, in SQL, you join tables with the join keyword. So let me just show you a very simple join here. So we're going to select name and someone as numFlights and you'll be like, well, wait a minute, name is not the name of a column in the flights table. So what are we doing selecting it from flights, which, by the way, we're abbreviating as F? Why are we selecting from flights? Well, that's not really how SQL thinks of it. SQL thinks, before I do that, I think of it as I'm selecting from flights joined up with airports on the basis of the dest variable in flights hooking up to the FAA variable in airports. And I'm only doing that where the origin in flights was JFK. And so then it makes sense that if I've grouped by dest down here, then this sum1 is counting up how many in each destination airport. And then we order by and limit in the usual way, and we'll get the same results as the dplyr command. So again, it's you kind of have some backward thinking that you have to do in order to make an SQL query as opposed to a dplyr one. Now, for a small query like this, it's not a big deal that we did it in the simple way, where we brought on the entire airports table, joined all of those extra columns that we didn't really need. In dplyr, it was very simple to just join on the 2 columns that we really needed. In SQL, ain't so simple, I'm afraid. In SQL, you can't just create new variables all of a sudden out of thin air. And I'm sorry, I'll take that all back. In SQL, you can do something similar, if you like, to make your query smaller. So instead of joining on just all of airports, you could join on the select FAA and name from the airports. But you got to be careful to group that up with parentheses so that SQL will know that that is what is now being abbreviated as the A. So this has the same effect, but in some sense it may be a simpler, quicker query. Here's a more elaborate wrangle, and then this will get us to the point I was about to make previously. Let's say we want to find the number of flights, the number of canceled flights, and the percentage of canceled flights from every New York City airport in 2013. So with dplyr, you might do it like this. You might take flights, and then you think, I need a new column that tells me whether or not a flight was actually canceled. And so we mutate to say that this new variable canceled is going to be if else. And what is it? Well, the criterion is if the departure time is non-assigned, that's the signal that the flight was canceled, then we're going to have a 1 in that column. But if the departure time was assigned, then the flight left. It wasn't canceled. We'll have a 0. And so then we could we could count up the canceled flights by summing along that column. And so then we'll group by origin, and then we'll summarize. The number of flights is just the number of rows in each group, but the number canceled is the sum of that canceled variable. So great, now we have the number canceled. We could add on a new column, percent canceled. It's just equal to the number of canceled divided by the number of flights times 100 to make it a percent. And then we'll be cool. There we go. So 2.6% of the flights from EWR in 2013 were canceled. Now, with SQL, it can be a lot more involved. I haven't really found a simpler way to do it myself than what I'm going to show you here. The reason that it can be tough is there's just no way to just like add a new column to a table in SQL. those tables, the understanding is that they're huge, huge tables that sit on a hard drive somewhere. And you can't just like add new columns to that enormous amount of stuff. And so everything is done through a kind of a reassembly in the query stage. So let's warm up to our problem by first considering, how would you make a table with a variable that says whether a flight was canceled or not? Let's try this out. From flights, we're going to select the result of a transformation function that's done with the case keyword. So this is like if else. Case. When dep time is null in SQL databases, the non-assigned values usually are written in as nulls, whereas in R you see NA. When dep time is null, then 1, else 0, and the end is marking the end of the case clause. So we're going to select that and name it the column canceled. We're also going to select out the flight number, the scheduled departure time, the month, and the day, just for fun. So you get an enormous table, and whoops, whoa, way too big. I'm trying to make this smaller, and I can't. My Mac. Okay, just a bunch of command minuses might get me where I need to go. Good Lord. Well, I'm pretty stuck, so I'm going to start this off in a new screencast. See y'all later.